and welcome to Elevate 2021. In my presentation for today, we are going to create a PowerBuilder application that runs in Azure using PowerServer with Docker containers. And also that same application is going to run with Kubernetes orchestration platform. My name is Filiberto Souza, and I'm the CEO of Sizes and Colors of Mexico. Disclaimer: this presentation was authored by volunteers in the Appian community. This is not a work for hire by Appian, and the views and opinions expressed in this presentation are those of the authors, in this case, myself. Please read on. Okay, let's start with the presentation. The session agenda. First of all, we are going to learn what are Docker containers. After that, we are going to explain what problems do Docker containers solve. And we are going to go through all the tools required for the development, and we are going to explore the Microsoft Azure portal. The first thing that we are going to do in the platform is creating a SQL database in Microsoft Azure, and we are going to run the PowerBuilder app with PowerServer that connects to the Azure database. Also, we're going to create a Docker image with SnapDevelop to Docker Hub, and we are going to run the application with PowerServer and a local Docker container. We are going to run also the app with PowerServer and a Docker container, but now we are going to create that container in Azure platform. After we understand what are Docker containers and what problems do they solve, we are going to learn what is the Kubernetes orchestration platform, and we are going to create the Kubernetes cluster in Azure. Once that we have created our cluster, we are ready to run the application with PowerServer and Azure Kubernetes, and we are going to see the difference in running the application just with a Docker container versus running the application with Azure Kubernetes. About myself, my name is Filiberto Souza, and I'm the CEO of Sizes and Colors of Mexico. I've been working with PowerBuilder for 27 years, also with Microsoft SQL Server for 15 years, .NET Data Store for 2 years, and C# for 2 years. On my recent projects from 2019 to 2021, we created a PowerBuilder application to integrate our ERP with marketplaces and e-commerce platforms like Walmart, Mercado Libre, Wish, Amazon, Electra, ClaroShop, Shopify, WooCommerce, BigCommerce, and PrestaShop. This application was made thanks to the new objects delivered by PowerBuilder, like the HTTP client, the REST client, the coder object, the crypter objects, and all these objects are needed in order to call the RESTful Web APIs. In the year 2021, we created Sizes QR Assistant, so it's a point of service for the true retail industry. And we created that service with .NET Data Store and PHP in the front end. In 2021, we started with a new project. We call it Sizes C2. Sizes C2 is a robot, and it is a fashion expert. So it is a PowerBuilder application integrated with artificial intelligence and machine learning to classify clothes, shoes, and accessories just by sending the picture of the item. This application is very helpful to our customers because It allows them to classify the merchandise by type of the product, by color, by characteristics of the product, and our customers are real happy with this solution. About our company, well, Sizes and Colors, it's an ERP software for chains of shoe stores. We've been building this software for 25 years in PowerBuilder, and Latin America is the target market. Today, more than 3,000 stores run our software on a daily basis, and it is deployed to the cloud at a data center in Dallas, Texas. We are for developers using PowerBuilder 2019 R3. And in 2019, our customers in Mexico sold 80 million pairs of shoes, representing the 30% of the commercial shoe activity. We are located in Leon, Mexico, and our sister company, Dora Sistemas, is a master distributor in Latin America for Appian. Okay, let's start. What are Docker containers? Well, a Docker container, it's an image. It's a lightweight standalone executable package of software that includes everything needed to run an application. So this image, it contains the kernel of the operating system, all the source code of our application, and it can be packaged in a lightweight and standalone executable package. It provides the tools to build a distributed application in a standardized way that can be packaged up and moved to all sorts of different systems. So we have our infrastructure, we have a host operating system, and we have our Docker manager that it's going to run all the containers in a different application in different containers. So what problems does Docker solve? It helps shipping some software from machine A to machine B reliably and automatically. So if you want to share your development with an environment with another developer, so you need to send from one computer to the other all the tools, the same version maybe of the programming language, all the settings. So you have this problem from shipping to the software from machine A to machine B. Also, if you are deploying to application to a server, so you are the developer, so you need to deploy your application to a server, you are shipping that software to the server. If you are scaling out from one server to multiple servers, so you need to pass this software to from this server to the other servers. So you are shipping software to multiple machines. So you are also, if you are migrating from one hosting to another, you need to ship that software from many servers to a new data center, or you are migrating from a private cloud to a public cloud, you are shipping software. If you are moving to a new data center, you are shipping software. So nowadays, our applications are every day more complicated, and they need to migrate to service-oriented architecture that interact with each other with different languages. So how Docker came up with the idea of a container? So Solomon Hykes, creator of Docker, found one example that had the same problem. The shipping industry in the 1950s, they had the same problem. They needed to ship products all around the world, and they didn't have a standardized way to ship those products. So the shipping industry has been around for centuries, and they had the same problem. So in the 1950s, people got together and agreed on a standard box, a format, a set of operations, and started using it. So the shipping container was born. If I want to ship coffee and all I have to do is put it in the container, close the door, seal it, and from that point on, getting the container to the other side of the world is not my problem. My infrastructure provider will take care of that, and all I have to do is wait for the container to show up in the other side of the world. The infrastructure provider does not have to worry about what's in the box. They have standardized cranes, standard boats. Um, they have trains, and they can deal with any container in the world because it is standard. Okay, use all the containers that you see, and they are standard size. So the shipping industry exploded after this invention. The container, it marked the beginning of the global trade, and it made the world smaller. The container is one of the few inventions that changed the world. It is an embarrassing situation when there is actually that the automation for shipping coffee around the world is better, more reliable than the kind of tools that we use to ship software between computers. Some from that point, they copy the idea of the shipping container for something similar for software. I, as a developer, should have a standardized way to take any software component, put it in some sort of box, and then handle to infrastructure providers, and do not worry on how long and how it is going to be deployed. And the operations team in charge in infrastructure should be able to do all sorts of things with that container without worrying about how I build it, what language I use, and that kind of stuff. So, thanks to the shipping industry, they came up with this idea of the container for the software. So, well, how the Docker solved the shipping problem? If you see, they as the shipping industry, they created a standard container format, and this gives simple tools for the developer to build his source code into a container regardless of the computer language, and gives to the infrastructure team simple tools to take that container without having to know what's in it and then run it. So these three things that Docker is doing, it's providing a standard format, it giving developers, helping developers to build those containers, and helping infrastructure providers to deploy and run the containers. That's what Docker is doing. Okay, if you want to compare, maybe you say, okay, if I in the past or nowadays, it is very common to use virtual machines. You have maybe if you want to create a similar environment of your software, so you simply create another virtual machine, and you have containers and virtual machines have very similar resource isolation and allocation benefits, but function differently because containers virtualize the operation system instead of hardware. Containers are more portable and efficient. If you take a look here at the image, with a container, you have the infrastructure, you have the host operating system, you have Docker, and you have all your applications running there. And what happens with the virtual machines? You have the infrastructure, you have the hypervisor, and for every virtual machine, you have a copy of the complete operating system. So you are wasting a lot of resources because the operating system takes a lot of space, takes a lot of RAM, takes a lot of CPU, and that's basically the difference between the containers and the virtual machines. That the containerized applications, they don't have the complete copy of the operating system. They just have the kernel, and that's it. So, for example, if you go to any cloud provider, if you rent a virtual machine, the virtual machine, you are going to pay for the 24 hours that the machine is running, or you need to turn it off at night, and it is very costly to have a virtual machine. But if you have the container is not it doesn't charge you for every hour that the container is on. So the containers basically they charge for every call to the application. So if you don't use the container in all day, it doesn't cost you anything. If your virtual machine, just by turning having it on, so you are going to pay a lot of money. So that's the difference between the containers and virtual machines. Okay, containers and virtual machines. Containers are an abstraction at the app layer that package code and dependencies together. Multiple containers can run on the same machine and share the operating system kernel with other containers, each running as isolated processes in user space. Containers take up less space than virtual machines. Container images are typically tens of megabytes in size and can handle more applications and require fewer virtual machines and operating system. So you see here, just you have your host operating system, you have the Docker, and all the applications running on different containers. On the other side, the virtual machines are an abstraction of physical hardware, turning one server into many servers. So you have the hypervisor, and then you have a copy. Every virtual machine has a copy of the guest operating system, taking a lot of hard space, CPU, and RAM. The hypervisor allows multiple VMs to run on a single machine, and each VM includes a full copy of the operating system, the application necessary binaries and libraries, taking up tens of gigabytes. VMs can also be slow to boot. And if you're going to move from monolithic applications to microservices, if you the only way to scale a monolithic application is adding more RAM, CPU, and disk space. This is a monolithic application puts all its functionality into a single process. So this is the type of application that we have today. This is our application, and we have all our functionality inside that application. And if we want to scale by replicating the monolithic on multiple servers, so we need to make a copy of our applications to multiple servers. And it is very expensive to the developer needs to have all the source code of the application in order to deploy a very small change, because we have just one application. If we want to make a small change, so the developer needs to have the complete application and deploy again. It is very expensive to do a new release because of development, testing, and deployment. And to solve this problem, microservices were born and allow many small applications to communicate between them. So this is a microservice architecture. If you hear, it's just one application. In here, with microservices, we are separating each functionality, each element of functionality into separate services. We have services right here, and scales by distributing these services across servers, replicating as needed. So if you are a developer and you have just this functionality, you just deploy this functionality, and you need to have the copy of all the source code. You don't need to wait for other developers, and you just deploy the service. Okay, now to start our project, first we need to create a SQL database in Microsoft Azure portal. Okay, so we are going to sign in, and we are going to the Azure portal. Here we have all the services that Azure provides to us, and we are going to create a SQL database. Here's the list of databases that I have right now. So let's just click on create. It is going to ask me for a resource group. I already have one. That's Appian Test. And I'm going to put a database name, HRDB Test 3. And it asks me for a location of the server. Okay, I want to see Elastic. I'm going to say no. Compute storage. Let's configure the database so it's a very inexpensive database. So it's for less demanding workloads. So we are just going to pay $4.99 per month for that specific database. Okay, so I have 2 gigabytes of storage, backup storage redundancy. I'm going to say locally. and that's it. And networking, I need to add my current IP address. Next, go to security. Um, Defender, not now. Okay, go to additional settings. I need sample data in my database, so I'm gonna put just sample here. Next, tabs, I don't need tabs, and then just select and review and create. Cost per month $4.99, and that's it. So I'm gonna create my database. It's doing the deployment. Okay, your deployment is complete. I'm going to go to the resource, and here's my database created. So what Azure does is creating me here an address appntest.database.windows.net. So I'm going to use SQL Server Management Studio so you can see our database. So I'm going to choose connect database engine. I'm putting here appntest.database.windows.net. I'm going to put my user and my password. I'm going to connect, and that's it. I can see my Azure DB test number 3, and I have, since I loaded the sample data, so I have some information in the tables. Here I have my customers, top 10. So here's all my data. So I'm connecting from my local computer to my database created in Azure. Okay, also, for example, if I want to connect directly from PowerBuilder, I want to create my ODBC to connect to PowerBuilder. So I create a DSN of the system. I select the native driver, and I'm going to put test 3. So it's appntest.database.windows.net. I'm gonna select my username and password. I'm gonna select default database, next, test, and is successfully. So now I can go to PowerBuilder and use the test 3 to connect to the database. Let's open PowerBuilder 2021. I'm gonna choose here my database. So I can create a new one. Is test number 3, my test 3. So I'm already connected to my Azure database in PowerBuilder. So I have here all my information. Now, if I want to run, this application, the PowerBuilder application. So I use connect with ODBC, Elevate demo. I put the name of my DSN, the username, and the password, and I'm going to connect to my my database in Azure with ODBC. So I'm connecting here, and that's it. I'm retrieving my information from the Azure database. Okay, so as you could see, you can create your PowerBuilder application that it's connecting with ODBC to your database in Azure, but remember that this is not the right way to create applications. You're compromising security and this is simply not the right way to develop. Um, so what Appian is doing here with PowerServer, let's do some changes right here. I'm going to put a comment, and we are going to create a PowerServer project, and I'm going to explain how it's done. Okay, here I need a cache name. I'm going to explain later how to create this. First of all, let's create the PowerServer project right here. You go to this tab, you create the PowerServer project. Okay, it is asking you for an application name. Okay, let's Elevate 2021 test 3. And before you continue, basically here I'm going to leave the defaults. It's full build, 32 bits, and the version. Okay, the first thing we need to do here is we need to have running IIS. So please make sure that IIS is running in your computer. Please check here that the Internet Information Services it's enabled in your computer, and just with the defaults, that's everything that you need. Okay, once that you have your IIS running, then what we need is to create in the C inetpub www root, we need to create a folder for that new website or that new applications. Elevate 2021 test number 3. Okay, so we have an empty folder right there, and let's create our application in PowerBuilder. Okay, so we have the name of the application, we have libraries, we have used one Pebble, external files. We are not using any external files in this application right now. In the runtime, okay, I need the REST client and maybe the ribbon bar support. So all the functionalities that you need in your application, you need to select them right here. Signing, I'm not signing this executable right now, and the client deployment. Okay, so I'm going to deploy this application to this local server, to my local machine, and I need a server configuration. Okay, I'm gonna change right here the folder. Okay, I forget to do something with my folder. I just need to right click and go to properties and go to security, and if I go to IIS users, I need to give full control, okay, to my folder in order that the application can be created. Okay, so I'm gonna change here, and I'm gonna test 3. I'm gonna test the file path, and it's connected successfully. Okay, I have the path. Now, the Cloud App Launcher, it's a very nice thing, and the main point here with PowerServer 2021, because in previous versions of PowerServer, remember that we had a dependency on the web browser. We needed Internet Explorer or Google Chrome, but we didn't like the idea to have this dependency on the web browser. So what Appian did right here with the new PowerServer 2021 is to create the Cloud App Launcher, that it's basically a web browser based on the Chromium. And Chromium, it's a free and open source code base for a web browser, principally developed and maintained by Google. So Google uses this code to make its Chrome browser, which has additional features. But for example, Microsoft Edge, Samsung Internet, Opera, and many other web browsers are based on these tools. So now we don't have a dependency on any other internet browser. So here, what we need to do, if you see your folder here, it's empty. So we need to upload the Cloud App Launcher. So when the user tries to download the application, and this app launcher is going to be loaded into the local machine. Okay, so let's upload the app launcher. If you see here, okay, I just created this, and it's copying all the files needed. This is like, remember, it's like the substitute for the web browser. So Appium has its own web browser integrated to load the applications. So just wait a couple seconds to finish the copy of the files. Okay, the Cloud App Launcher installer it's loaded to the server successfully. So it uploaded the Cloud App Launcher to my local server. Okay, so we are ready with the server configuration. We leave just the defaults right here in the run options. So we don't have to do anything right here. Okay, we need to go also and create a default a website, okay, in IIS. So we can define here the port. Okay, let's go to IIS and create a new website right here. Add a new website. Name of the site is Elevate 2021 test number 3. The access, okay, I'm gonna select that new folder, and I'm gonna select a new port, 8087. I want to this website to run in that port, and that's it. Okay, so we have our view go, and your website is running right now. Now, here you put localhost and you port the port 8087, and that's it. This is how your application it's going to run. And now let's go to the web APIs. Okay, here I'm gonna select a new test number 3. I'm gonna select a solution name. I'm not using authentication in this application right now. And I'm going to auto import the license for PowerServer. Okay, to connect to your application, remember we need a connection cache right here. So I'm gonna select new, and I'm gonna say DB in Azure test number 3. And I'm gonna connect to my database here. It's I'm going to tell my application how to connect to the database. Remember, we have our database in Azure, so let's connect to that database. DB in Azure test number 3. I'm gonna select the provider. Okay, I have Informix, MySQL, Oracle, Postgres, SQL Anywhere, and my database is in SQL Server. So remember the host of my database in Azure. Okay, if I'm going to Azure, I'm going to select, I'm going to my databases, SQL databases. This is for my tests. Remember that Azure assigns a server, a domain for the server name of my databases. So it's appium-test.database. I'm gonna just copy. I'm going to PowerBuilder and just paste it. Okay, I don't have Windows authentication. I have SQL Server authentication. I put my username and my password, and I'm gonna test my connection. Okay, first of all, I need to put my the name of my database. Okay, the databases are loading. Okay, I'm gonna test my connection, and that's it. I have a successful connection to Azure. Okay, so this is the database configuration for the app compilation, and now we need to transactions for the mapping. So I can define, for example, right here, that my SQL CA connect transaction object, it's going to map to the DB in Azure 3. So this is the cache name that just created. I'm gonna put this one, I'm gonna set as current, and that's it. I'm gonna click here on the DB drivers. I need just to agree that the driver is available as a NuGet package under this license agreement, and I just select that I have read and agreed the license terms. Okay, and that's it. So I have right now my PowerServer project ready to run. I'm gonna put it the name test number 3, and that's it. Okay, so basically what I need to do is build and deploy the PowerServer project. I need to close this application right here. Okay, I need to do some change. I saw here. My cache name, it's DB in Azure test number 3. Okay, and that's it. Now I open my project again, and I'm gonna deploy. Okay, that's it. Now what I need to do is I need to compile and run the web APIs. Remember that, for example, this screen, all the visible objects are going to run in the local machine, but the web APIs are the ones that are going to be uploaded to the web server. Maybe they're going to be running on a container in Azure. We are going to do an example later of this. But what Appian is doing is taking all the business logic into web APIs, so the information can be accessed. So what we need to do here is compile and run the web APIs. Here is the Kestrel showing up. The Kestrel is a web server that we are using in order to access the web APIs. So now we are not accessing directly the database as we did in the PowerBuilder applications. We have someone in the middle that it's the web server that is responding for those web APIs calls. And now I can run the PowerServer project. And that's it. I have my information. Remember, the database, it's in Azure, and now the project is running with PowerServer and not PowerBuilder. But we are using, we are not relying on the web browser. If you go here to my desktop, so we have the application here. It's an icon. It's an application. We run it. And that's it. So we don't have any dependencies on web browsers like Internet Explorer, Microsoft Edge, or Google Chrome. We are going to continue with the PowerServer example. Another thing that I wanted to say is that with the PowerServer 2021, the great advantage is that you can use 99.9% of the PowerBuilder features, since you're using the PowerBuilder virtual machine. Okay, so all the objects are supported. You can use the web browser, all the ribbon bar control, and those controls were not supported in previous releases of PowerServer. So now with this PowerServer 2021, you can take advantage of all the objects. Okay, so we take a look of the example here in PowerServer running locally, not using containers. So now we are moving and going to run this same application using a container. But for that, first of all, we need to create an image. To create a Docker image, first of all, you need to install Docker Desktop. Okay, Docker Desktop is the one that is going to help us to run the container locally. And also with Docker Desktop, we are going to upload our image to Docker Hub. Okay, so you need to open also an account in Docker Hub. Okay, you just it's free. You just open an account, and that's where you are going to store the images of your containers. Okay, so once that you install the Docker desktop on your development machine, okay, let's go to PowerBuilder, and we are going to open our solution in SnapDevelop. Remember, SnapDevelop is the IDE for C# created by Appian, and it's a very lightweight compiler compared to Visual Studio. It opens very fast, and it has all you need to create web APIs. Okay, so our project it's open in SnapDevelop, and now you can see here PowerServer generates all the server APIs. If you can see here the models of your data window in our application, we just have one data window, data window products. So as you can see, SnapDevelop, it's creating all the C# models for this data window. Is basically all the columns that I have in my data window. If we open our data window right here, and we will see the source, convert to syntax. Okay, here are all the columns that we have in our data window, and what SnapDevelop is doing, it's converting that data window to a C# model. Okay, so we have the C# model, and what we need to do is to create the image. Remember what I told you about Docker containers, that they created this format, this standard format, in order to the container to be able to run by any infrastructure provider. So that's what SnapDevelop is helping us right here. Okay, we are going to right click on server APIs, and we are going to click publish. And as you can see here, you can do a web deploy, a file system, and here is a Docker container. Okay, let's go into click start. That's a local host. That's the registry on my hub.docker.com. I have the name of my APIs, server APIs, test number 10, and latest. So that's everything you need to do. If you see here on my Docker desktop, I have some of the images right here, test. Okay, you cannot see here at test number 10 as I'm putting it right here. Server APIs test number 10. So once we are going to finish. So what SnapDevelop is doing there is creating the image that later on is going to run as a container, okay? And that container can be running on Amazon Web Services, on Azure, on Google, and any infrastructure provider. Okay, it's doing all the deployment. Succeeded. So now SnapDevelop created the Docker image for us. If we go to Docker desktop, here you can see the server APIs test number 10. Okay. And also what Docker desktop, it uploads our image to Docker Hub. Let's see if we have it right here. Test number 10. Let's just refresh. Here it is. Okay, so server APIs is right here. APIs test number 10. And what Docker Hub does is that it verifies the format of your image. And later on, when we create our container in Azure, we are going to specify this address. So Azure is going to connect with Docker Hub to get the image and run the container. Okay, that's we are going to do that later. First of all, what I want to show you, it's before going to create the container in Azure, Let's run the PowerServer project with the local container. Okay, if we go here to SnapDevelop, to the Docker desktop, if you see here, okay, we don't our image, we don't have a container yet for server app is test number 10. So what we can do is we go right here to SnapDevelop, we go to view, and we go to the Docker Explorer, we have our local host, and we have the images that we just created. Okay, here we just right click on and test number 10, and we run this image as a container. Okay, let's put the name to the container. That's a container that I'm running. I need to put my local IP. Let me get my IP config. I need to get the local IP of my machine. 92. I'm gonna be listening for port 5000 for the web API calls, and that's it. We can. Okay, so our container is running right now, listening on port 5000 for web API calls. If we go to the Docker desktop, we can see here our Elevate 2021 test number 13 is running. Okay, so now we can go to the PowerServer and see here is the IP of the project. Let's just deploy it. And run the PowerServer project. Remember that our web APIs are running right now as a Docker container. So we don't need to do the compile and run of the web APIs with the web server Kestrel, because now Docker is doing that job. And that's it. We have our application running with PowerServer and a local container. Now, the local containers are basically for your testing and development. But now, if we want to go to production and really take advantage of what containers are, let's go and create the container in Azure. Creating the container in Azure, it's easier than you think. Just let's go to Azure and let's go to Azure Services and Container Instances. Here I created just a couple containers for my testing, but now let's create a new one. Create a container instance. Well, first of all, it asked me for a resource group for containers. I created this resource group. Now, container name, I'm going to create a version 4 of my container. And here is where I specify that it is a Docker Hub container. If you go to Docker Hub, you see the containers that I have right here. So Appian, Azure is going to import this image from Docker Hub and run it as a container. Let's go right here, Appian test server APIs. It needs to be the same name, Appian test server APIs. That's it. It's a Linux container and a DNS label. It's Elevate 2021 version number 4. And that's it. We are ready to create our container. It's doing the deployment of the container. And the nice thing is that you don't need to do the administration of the Windows server Microsoft is going to do everything for you, and the container, remember, it doesn't charge you per hour. If your virtual machine is turned on all day long, you're going to pay for the 24 hours. And with a container, basically you pay for the number of requests. So it is a cheaper solution. Okay, so we have our container created, and they give us a DNS. So I just copy this to the clipboard. Let's go to PowerBuilder, and I'm gonna I was doing test with version 3, but now let's do test with version number 4, 80. I'm gonna save. I'm gonna do deployment, and then I'm going to run the PowerServer project. That's it. Our application is running. What happens if I stop the container? Let's stop the container. Yes, it's already stopped. So let's retrieve, and it is going to send me an error. I mean, as you can see, it's not getting the information from the database. Let me try to run it right here. It is going to send me the error that is not finding the container. Failed to send the request to the web API. So we need to just turn it on again. Start the container. Okay, now we can see it is running. So let's go again and run our PowerServer project. And here we have our application running. Okay, so now we just did the creation of the Docker image. We uploaded that image to the Docker Hub. Then from Docker Hub, we were able to create our container in Azure. And now that we know how to run our application with a container in Azure, now let's go and talk about Kubernetes. Let me go change to the presentation. Okay, what is Kubernetes? First of all, the word Kubernetes comes from Kubernetes in Greek for helmsman. So now we have when you have a lot of containers, you need someone to take care of the administration, and that's why Kubernetes was released. Kubernetes is an open source orchestration software that provides an API to control how and where those containers will run. The Kubernetes were released as an open source by Google in the year 2014, and it allows you to run Docker containers and workloads and help you to tackle some of the operating complexities when moving to scale multiple containers deploy across multiple servers. Okay, when you have just a few containers, you can just run them directly. But when you have hundreds of containers, then you need the Kubernetes orchestration platform. Kubernetes lets you orchestrate a cluster of virtual machines and schedule containers to run on those virtual machines based on their available compute resources and the resource requirement for each container. Containers are grouped into pods, the basic operational unit for Kubernetes, and these containers and pods can be scaled to your desired state, and you're able to manage their life cycle to keep your apps up and running. So the Kubernetes versus Docker question. I mean, should I use Kubernetes or Docker? This is like comparing apples to an apple pie, and it is a common misconception that you must choose one or the other. So to create the apple pie, you need the apples. So I mean, Kubernetes really need the containers, the Docker containers, in order to work. So the fact is, you do not have to choose. Kubernetes and Docker are fundamentally different technologies that work well together for building, delivering, and scaling containerized apps. Okay, how do Kubernetes work? As applications grow to span multiple containers deployed across multiple servers, operating that becomes more complex. So while Docker provides an open standard for packaging and distributing containerized apps, the potential complexities can add up fast. Kubernetes can coordinate and schedule many containers, help containers in your app talk to each other, and scale many container instances. So when you have many containers, you need Kubernetes. How do these work? Okay, let me show you. Here we have the worker nodes. We have a Docker inside each one of the worker nodes, and Docker communicates in this case to the image registry like Docker Hub, where you are going to import all the images so your container can run in each worker node. For example, you can have the Kubernetes can do something like you can say, okay, I use one instance of this container. I want 5 instances of this container. And why? Because maybe this container has more workload, so you need more of them. And you can have also 2 times this group of containers. So as you can see, this is 5x, so you have 5 times the container running in different workloads. So it helps you to do load balancing when you have many containers. So now let's explain a little bit how the Kubernetes work. Here you have the Kubernetes master. That this is very important to coordinate everything that's going on with all of your worker nodes. Here you have a 1 worker node, 2, 3 of them. And you to create the Kubernetes, you need files, YAML files. The extension YAML, it's comes from just another markup language in which you're going to specify what kind of, if you're going to create a deployment or if you're going to deploy a service. Here, for example, in each worker node, you are going to have a pod. And what is a pod? It's the smaller unit of in the Kubernetes. And the pod is really a group of containers. It can be used 1 or 2 containers. So here you have your pods, and when you create a pod, you get a local IP. But what happens if this pod goes down? When you started the game, you get a different IP. So what Kubernetes created was they created the service, and when you create a service for this for these worker nodes, what you create it's a cluster IP. So this cluster IP it's a stable IP because if one of the pods goes down, I mean it is still the same IP address, and they can access a different pods on a different worker node. So once that you have your service IP, you can have another group of pods. This is another application B as a backend, and these applications can communicate through this cluster IP that's created for each one. And also, when you want to put the web API to to the client machine, then you have your external IP. So this is kind of how the Kubernetes work. They help you to in the service. For example, you are going to specify the load balancer, and here you in the deployment you specify how many replicas you have or the of this container. So you say 3 replicas, so you have 1, 2, and 3. So this is basically how Kubernetes work. Um, After I go to the demo, now let's go to the. I'm gonna first. I want to show you the before we go to Azure to create our Kubernetes. I just want to show you the files. Okay, this is the deployment, just another markup language file for the Kubernetes. So first of all, here I have the deployment file. In the deployment file, I'm gonna have the name of my application, and I'm gonna specify how many replicas I have of this application. On the other side, I have the okay, this is the same file. Metadata, I have the name of the application, the port where this application is going to be running, and I have another file. Is the service, just another markup language for the Kubernetes. In with this service, remember that the service is going to help us to create a cluster IP, so it is an unstable IP. And here we have it's a service. We specify the name of the application, and here we need to put the type. It's a load balancer. So these are the two files that you need in order to create your Kubernetes cluster. In the other one, for the deployment, I forgot to explain that here in the specifications, I have the containers, and here is where you put the address of your image in the Docker Hub. So it can go to Docker Hub and import this image. Okay, so we have the theory explained of how Kubernetes work. Now let's go to Azure and create our Kubernetes. Okay, here we are in Azure. Let's go to all services. We can search right here for Kubernetes. Here is our Kubernetes service. I have this Kubernetes, which is the one I created for my test, but let's create a new one. Create a Kubernetes cluster. For the resource group, I created a group for Kubernetes for this event, and I'm gonna choose a name. Elevate 2021 version number 4. Here you can specify the region, availability zones, Kubernetes version. Just basically get the default. This is for the subscription manual. Okay, let's get another South Central, US South Central. Okay, let's see. Okay. Let's put right here manual. It'll be a simple Kubernetes cluster. I have just 3 nodes on this cluster. Let's go to the pods. Just basically leave all the defaults in the authentication defaults next to the networking. It's a Kubernetes. This is the DNS. Security. Okay, let's leave all the defaults. Integrations. Container registry, known. HR policy. Now let's tags, not tags, review and create. Okay, validation pass. Now we are ready to create our Kubernetes cluster. Deployment is in progress. It is deploying our Kubernetes. Okay, now our deployment is complete. Let's go to the resource to Kubernetes was just created. It is already running, but now we need to do run our files in order to do the configuration of the Kubernetes. Okay, so we need to run the Cloud Shell and run the following commands. So I'm gonna open here the Cloud Shell. It's a Linux-based command. So I'm gonna copy this command first. I'm gonna do a copy and I'm gonna do a paste. Okay, and then I'm gonna do also a copy and I'm gonna do a paste. Okay, now I need to upload the files for the service and for the deployment. Deploy demo. Deploy demo. Deploy demo. If you can list it right here as Linux. Okay, you have the deploy demo. And we need to upload also the file service demo. ls. Okay, you put it again. It's deploy. Code deploy demo. So here we have the contents of the file, and also we have the okay quit. Don't save. I'm gonna do code service demo. Here we have the contents of our service file. Okay, I'm gonna exit, quit, and I'm gonna use a kubectl to get our deployments. So we don't have deployments yet because we need to apply it. Okay, let's get kubectl apply deploy demo dot just another markup language. Okay, it's created. Now kubectl get deployments. Now we have our deployments. Now we need to apply our service. If you go to kubectl get, well, let's do first the apply service demo. And we have the service. So if we go to kubectl and get the services, kubectl get services. Okay, so here's the IP address that we should use in PowerServer in order to run our Kubernetes. So with this, the Kubernetes is already created, and now let's go use PowerBuilder. I'm gonna use another one. It's the one that I tested. Let's go to here to Kubernetes. I'm gonna select Elevate 2021. I'm gonna close right here. If I go here and use kubectl get services, this is the IP that I'm gonna be using for this power server. Okay, it's 2088 to 3830. Okay, I'm gonna deploy, and I'm going to run. And that's it. Our PowerBuilder application is running with a Kubernetes in Azure. Okay, so that's it. Basically, we got all our demos running. We did 5 examples on how we can connect to the Azure SQL Database. And in our first example, we basically just had the normal client-server application, PowerBuilder application, running the executable file from your desktop. And in the middle tier, we didn't have anything in the middle, and we don't really like that approach because there is a direct connection to the database, and that's not secure, and this is slow performance. Even though PowerBuilder allows you to do that, we do not recommend it, but you can connect to the Azure database. And the nice thing of having your database in the cloud with Azure is that you don't need to administer Windows Server and Microsoft SQL Server software. Okay, in our second example, we had the PowerBuilder application, but now we use PowerServer 2021 that uses the Cloud App Launcher and not the executable. With that, what PowerBuilder generates, it generates web APIs, and for the testing and development, basically uses the Kestrel web server that runs the PowerServer web APIs on the local machine, and they connect to the Azure SQL database. It responds to the web APIs and not directly from the PowerServer application. So it goes to the web APIs, and those web APIs make the call to the database. On the next example, we basically had the same PowerBuilder application with PowerServer 2021 using the Cloud App Launcher. The Cloud App Launcher, like in the last example, well, it's like a web browser, and it is based on Chromium, and it allows to PowerServer in previous releases. It was relying on the Internet Explorer, on Microsoft Edge, and now there is not that dependency anymore. In the middle tier, in this example, we use Docker running the container on Linux on the local machine for testing and development. Here, PowerServer helped us to create the image with SnapDevelop, and that image has a web APIs that can run as a container in Docker. So that this example of running Docker on a container on Linux on the local machine is basically for testing and development. And we could connect also to the Azure database. Docker is running, and the containers, which has the web APIs that make the calls to the database. And these two examples were for testing and development in the local machine. But now we needed to take that Docker container to Azure, to the cloud. And we also use the PowerBuilder application with PowerServer 2021 using the Cloud App Launcher, which also has the PBVM that runs most of the PowerBuilder objects. In previous releases of PowerServer, we didn't have the compatibility or the support for all the PowerBuilder objects. So now you can use most of them. And in the middle tier, now we created an Azure Docker container that gets an image from Docker Hub. Remember that the image that's created with SnapDevelop in the local machine, it goes to Docker Desktop, and then Docker Desktop uploads it to Docker Hub, and then when you create the container in Docker, it basically imports the image from Docker Hub with the code of the web APIs. The PowerServer application makes the call to the container. And the nice thing of having the Docker container is that you don't need to administer Linux server for the container. Azure does everything for you. And now we have the container in Azure, and also we have the database in Azure. So the web APIs that are running the Docker container, which make the calls to the Azure SQL database. So now we have everything in Azure, the web APIs and the SQL database. We went to learn a little bit about Azure Kubernetes, and we had the PowerBuilder application with PowerServer 2021 using the Cloud App Launcher, which also updates the application automatically from the application web server each time a new version is available. So we have a web server which, when we compile the application, it goes there, and all the users, when they load the application, it checks for the latest version, and if we have a new version, it automatically updates. So in the middle tier, we created the Azure Kubernetes cluster that runs all the Docker containers. When one pod fails, the Kubernetes has replicas to take their place. Also, the Kubernetes works as a load balancer. So we recommend using Kubernetes when having a lot of containers. And in the database, well, the web APIs are running in the pod of the Kubernetes cluster, which make the calls to the Azure SQL database. So that's basically what we wanted to show you, that with the latest version of PowerBuilder 2021 and PowerServer 2021, you can create applications in the cloud. In this example, we selected Azure to create the containers, to create the Kubernetes, and also to create the database. Thank you very much, and I'm here to ask any questions that you may have.